Okay. Yeah. Now I'm audible.
Yes, sir, you're audible.
Okay. Okay, fine. See, in this case, I'm having this collection, and this collection having this number of elements, right? And first of all, I'm printing the element, right? Let me add some duplicate element, removing Sri Lanka, right? So Sri Lanka is there. I'm adding Sri Lanka again at the end of the collection, right? To make sure it is going to remove this element only once, right? So here I'm using a remove method to remove this Sri Lanka element. And after removing this element, I'm just printing the count. So in this case, the count is going to be decreased by 1, not 2, because Sri Lanka is available 2 times, but it is going to remove only 1, right? And then I'm removing the element by using the remove at method and by using the index position, right? I'm removing the element by using the index position. In this case, you can see in this case it is going to reduce the element by 1. So here we are using a remove method, and here we are using a remove at method. And another option is that you can use the remove all method, right? This remove all method, if you go to the definition of this method, right? If you go to the definition of this, what? Okay. If you go to the definition of this method, then you will see that after removing the number of elements, it is returning me an integer value, and this integer value indicate the number of elements removed by this remove all method, right? So this is the reason why I'm implementing that logic here, so that how many number of elements is removed, that number it is going to print here, right? So in this case, what logic I have written, I'm providing one predicate, right? So here I'm providing one lambda expression specifying that one condition. What condition? I'm specifying x. X in this case, the elements, right? The elements whose length is less than 3, please remove this. So in our example, this is one element and this is one element, right? So in this case, these two element it is going to remove, because these two element are having the length which is less than 3. Clear, guys?
Yes, sir, yes, correct.
And in this case, I'm using a remove range method. So it is going to remove 2 elements from the index position 0. You can specify 1, that is also fine, right? From the index position 1, it is going to remove 2 elements, or from 0, it is going to remove 2 elements, right? Or it is up to you from which index position and how many elements you want to remove, that you need to specify by using these 2 parameters. First parameter indicating the index position, and the second parameter indicating the number of elements to be removed from this index position. And you
Start and
know,
the end. Is it start and the end? This
no,
is
no,
start.
no, it is not start and end. It is start, and this is the number of elements.
Oh, okay. Up to that.
Yeah. Suppose you are specifying 0 and 2 means from the 0th index position, it is going to remove 2 elements.
Okay.
If you specify 5, then from the 0th index position, it is going to remove 5 elements, right?
Oh.
And this clear method means it is going to remove all the elements. And here I'm using this count properties. Let me run the application. Right? Total number of elements is 12. Sri Lanka, after removing, the count is going to be 11. But if you look at the collection Sri Lanka, how many times appeared? 2 times. Yes or no?
Yeah, 2 times.
But after removing Sri Lanka, how many count decreased? 1 or 2?
One only. One.
That means the first element, what it found, that element is going to be removed, right? The remove method will remove the first occurrence of the element, right? This is the first occurrence, this element is removed, right? After removing index 2 element, right? Suppose I'm removing from the index position 2, I remove one element, right? That element which is available at index position 2, I have removed that element, right? After removing, the index position will become, so the number of element will be decreased to 10. Then the remove all element, remove 2 elements. Why? Because in this collection, 2 elements are there whose length is less than 3. So in this case, UK and NZ. These two elements are removed, and after removing those two elements, the length becomes 8, right? After remove range method, element count becomes 6 because by using this remove range method, we are deleting two elements. Yes or no? From the index position 0, we are deleting two elements, so the count becomes 6. And after the clear method, the count becomes 0. Clear?
Yes.
Right? So this is how the remove method or all the remove methods are worked in our collection, right? Now, as of now, what we have discussed the collection classes. We have discussed how to perform the insert, add, remove, all these things, right? Collection, initializer, how we can access the element. But if you remember all the things, all the examples, what we have so far discussed, they are working on the primitive data types, right? Primitive data types means they are holding the value, right? Value type data type you can consider apart from in this case. Now, what we are going to discuss, instead of using the built-in data type, right? So these are nothing but integer string, all are built-in data type, right? Now, what we are going to discuss how to use this list collection class with user-defined complex type. User-defined complex type. Let me show you this practically, right? Whatever operations we have so far discussed, the same operation we are going to discuss. So in this case, this employee is a type or not? It's a user defined data type, right? And this data type is created by using the class. So instead of using integer string for all these things, you can also create a list of employees, right? You can create a list to store a collection of employees. And if you want to store a collection of employees in a, right? Then what should be the type? The type is going to be employees. Clear?
Yeah.
So in this case, this list employees collection is going to hold element of this type. And you can see initially I have created 3 employees, right? And if you go to the definition, so this employee class having 4 properties, and I'm simply creating 4 employee object, name employee 1, employee 2, and employee 3, right? And you know how to add elements to the collection, right? You know how to add elements to a collection, the same add method. But in this case, this add method accept the type parameter, which is nothing but an instance of this employee class. Is this emp1 is an instance, or is this emp1 type is employee? Go to emp1, yes, the type is employee. So you can pass that object here, like employee 2, employee 3. So I'm adding these 3 elements, right? These 3 objects into my list employees collection. That is fine. Right now. Now, retrieve the first element by index position, right? The way you retrieve the element, in the same way, you can also retrieve the element using using this user-defined type, right? So list of employees 0. This list of employees 0 means this element is going to be returned or not. This emp1 is stored inside this 0th index position or not?
Correct. 0th
Yeah.
position.
And what is the type of this element?
Employee, sir.
Employee. That means to store the data, you need a type of the same employee or
Yeah.
not? So
Yeah.
here employee, first employee. I'm providing the name as first employee. If it's a string type, then you can store the value in a string variable. But this value emp1, it's a type of employee. So I need to create one employee variable to store the value. And then I'm simply printing the ID, the name, the gender, and the salary.
Okay.
Right? The 4 properties I'm just printing. So using the index position, you can access, right? And using the for loop, you can also access. In this case, this loop variable is pointing to the index position. And by using that index position, I can simply get the employee data and I can print the employee data, right? This is the same thing. What we have used here, this is the same logic. Here we have hard coded the value 0. And here the value is nothing but your counter variable or loop variable, which is going to be 0, 1, and 2. Even though you can access the employee information using a for each loop, right? We have already seen this thing using our simple type. So again, you can access this information by using the for each loop, right? How this is the process. So list of employee, each employee is going to start in this variable, and from this variable we are just fetching the ID name, gender, and salary, right? So now what I'm trying to do is I'm creating a new employee. So this is my employee 4, right? And using this insert method, and if you want to insert this employee at the index position 1, then you can also insert this employee. And if you want to insert this employee object at the end of the collection, then which method you need to use?
Employees.
See, in this case, what is the difference between these two statements? Can anybody tell me?
Add will add the employee at end. Insert will add the employee at the specified position.
Exactly. So this employee location is going to be second, and in this case, the employee is going to add at the end of the collection, right? We have already seen this thing. Let me add. So in this case, this employee 4, it is not going to be added at the 4th position, right? Or you can say at the index position 3, it will be added at the index position 1, right? So then I'm simply using a for each loop, right? For each loop to print all the employee information, and here I'm just showing you the index position. Okay, let me okay, and if you want to know what is the index position, employee 3 object in the list, so it should be employee 4, right? Employee 4 object in the list, what is the index position that it is going to return, right? Let me run the application. See, retrieve the first employee. Who is going to be our first employee in this collection? Who is Pranay? So you can see the ID whose employee ID is 101. That is our first employee. That information is printed here. Then I'm retrieving all the employees using for loop. You can see all the 3 employees. Retrieving all employees using for each loop. You can see for each loop. Then I have added a new employee, right? And what is the name of the employee? 104 and Samvit. But at what index position we have added? Index position 1. So you can see this is 0th index position. This is 1th index position. In 1 index position, this ID 104 will come or not. And then I'm checking the index of employee 4 object in the list is 1. Clear? So all the operations what we have discussed, the contents method, right, the remove method, everything is also applicable to this list collection class. Clear?
Yes.
Right. Now, the next important topic, what we are going to discuss, sorting functionality. Right. We have discussed the search functionality, how to find whether an element is exist or not, right? Or how to sort the elements of a collection. That is what we are going to discuss, right? Sorting. Why sorting is important? Because sorting a primitive data type and sorting a complex data type is going to be different, right? How to sort a complex type like employee, customer, product, department, but our main agenda is to sort a complex type, right? Complex type. But before understanding the complex type, first of all we need to understand how to sort elements using how to sort primitive type data or simple data types, right? Now if you go to the definition of this list collection class, then you will see that there are 4 sort methods. You will see that 4 sort methods, right? So one sort method taking integer index, integer count, and one comparer. Another sort method will taking one comparison delegate, and another method is taking I comparer interface, and another method does not take any parameter, right? So we are going to discuss these 4 methods and how we are going to use those 4 methods. That is what we are going to discuss, right? Now, suppose you are a collection like this, right? You are having one integer collection where you are storing 18752. If you call this sort method, then the data is going to be sorted in the ascending order, right? 1, 2, 5, 7, 8. The data in the list will become 1, 2, 5, 7, 8. And if you want to if you want to sort the data in the reverse order, after calling the sort method, then you need to call the reverse method, which will sort the data in the form of its reverse order. Reverse. Don't think that reverse means descending. Reverse means it will simply reverse the data. Reverse the data in the sense, suppose you are not calling this method, right? Suppose you are not calling the sort method directly on this, you are calling the reverse method. Reverse method means in this case, it will just reverse the data. In this case, in 0th location, one's first location is 8. So that what will become, instead of 18752, it will store the data in the reverse order. That is, first 2 will come, then 5, then 7, then 8, then 1. Right? Don't consider that sort. See, sort means ascending, that is fixed. But don't consider reverse means descending. Reverse means it is not descending, it is means it will store the data in the reverse order. Reverse order in the sense, the element which is stored in the last position will become the first element in the collection. Clear?
Yes. Yes.
Yeah. But once you call this data, once you call the sort method, and then if you call the reverse method, means the data is
It will
going to
be
be in descending order.
descending order.
Right? But if you are not calling this method, then don't assume that, don't expect that the data is going to be in reverse order. I will show you this thing practically. Okay. Let me run. Okay, let me copy the code. Okay, this is my collection, and this is my data before sorting. Right? This is my original data. Then I'm calling the sort method, and then I'm printing the data after sorting. Right? Then I'm calling the reverse method, right? And then I'm printing the data. In this case, the data is sorted in ascending order, right? And even though you can also do the same thing using a string collection, right? In this case, this is my string data before sorting, right? Then I'm calling the sort method, then the names after sorting, and this data or name in descending order. So in this case, data is in descending order because of this sort data. In this case, you will see the numbers in descending order, right? Because of this sort method, right? Let me run the application. See, so you can see my original data 18752. After sorting, it becomes 12578. Descending order means 87521. Right? The names before sorting is the sequence name. After sorting, it is ascending based on the alphabetical order. It sorted the data, and this descending means it is nothing but your reverse order. But in this case, the data is already sorted, means you can consider this as a descending order. Now what I'm trying to do is I'm just commenting this statement, right? Because people are getting confused. What they confused now, they just call the sort method. They are thinking that the data is sorted, and they think that when I call the reverse method, the data is going to be in the reverse order, right? So in this case, you can say I'm not calling the sorted method, right? Instead of saying this descending order, it is better to say data in reverse order. So this is not the right. It is better to say data is in reverse order, right? And in this case, let me run the application. See, number before sorting, number in reverse order. Do you think that, do you see the data is in descending order or in reverse order?
Reverse order.
Reverse order. In this case, whatever last, that will become the first. 5 will become second, 7 is third, 8 is the fourth element, 1 is the last. And the same in the case of a string data also. You can see Rakesh, Hina, Sambit, Anurag, and Pranay. In that sequence, the data is going to be printed once you call the reverse. So the first confusion should not be on your mind that reverse method is going to sort the data in descending order. Sort method is going to 100% sort the data in ascending order, but reverse method is not going to sort the data in descending order. Rather, it will store the data in the reverse order. Clear? Guys?
Yes. Clear.
Okay, that is fine. Now, now what I'm going to show you is I'm creating a collection, right? Employee collection, and I'm having this list employees collection, right? And then I'm having this employees before sorting, and here I'm calling the sort method, and then I'm calling this after sorting. After sorting the data, I'm looping through the collection and printing the value, right? Let me run the application and show you what happened. What happened? We are getting the exception. We are getting the error. Failed to compare two elements in the array. Can anybody tell me why we are getting this error?
It says at least one object must implement comparable.
Yes, object must implement comparable interface. That is the solution. But why we are getting the error? Okay. Okay. Now tell me, how many elements are there in your employee class? 4 elements. Then if you are calling the sort method, then how the runtime, how the .NET framework know, is .NET framework know that you are going to sort the data in based on the ID value, based on the name value, based on the gender value, based on the salary value? Does the .NET framework have any idea
No.
based on what condition, whether you want to sort the data based on ID and the name column, or whether you want to sort the data only based on the salary column, or you want to sort the data in the name color in ascending order or name in descending order, right? Any idea about this to the .NET framework? Does .NET framework know this thing?
No.
No. So it is completely based on my requirement. Now, I want to sort the data in name ascending order. I want to sort the data in salary column. I want to sort the data based on the name and gender column, right? This is completely my personal requirement. But coming to the previous example, right? In the previous example, this thing is not coming to the picture because they are directly the value, right? In this case, they are directly the values. Values means there you can store only one value, right? 1 is a value, 8 is a value, 7 is a value. So directly they can store the data like this, right? And it's a built-in data type, right? And coming to this employee class does not have, I mean, this employee class means it's your own data type, right? And it's your own data type means you have to provide the logic to sort the data, right? And then you might be one question, sir, in this case, it is not working. It is throwing me one error indicating that you have failed to compare two elements, and at least one object must implement comparable interface. So in this case, I'm not implementing the comparable interface. That is fine. But even if I'm creating an integer type, right? In this case, you can see. In this case, if I'm storing integer data type, then how it is working fine? Yes, it is working fine because if you go to the built-in data type, whatever we use integer string, then you will see that they implement this comparable interface, right? If you go to the definition of integer, then you will see that they implement this comparable interface, right? If you go to the string class, right? If you go to the string class, then you will see that that class also implement this comparable interface, right? So the point that you need to remember is, now for a built-in data type, if that type implement the comparable interface, then this sort method is going to work as expected. But if you are creating your own data type, and if you have not implement the comparable interface, then you cannot call this sort method. And if you try to call this sort method, then you will get this exception that you have not implement comparable interface and you are trying to compare two objects. Clear?
Yes.
Right? So now what is our requirement? We need to understand this comparable interface. What is this comparable interface? How to implement this comparable interface in my employee class, and how I can specify the condition based on which the data is going to be sorted. And then we will see that when we call this sort method, the data is going to be sorted based on the condition or based on the logic what we implement in our comparable interface. Yeah, someone asking me any question?
I think I was asking the same question, that like how it will come to know that which
Okay,
parameter
fine.
it will consider to
Yeah,
solve.
that is what we are going to discuss. I cannot left in middle of the things, right? So I am going to explain this thing now, right? So that is what we need to understand, right? Okay, right. Say if you go to the comparable interface, right? Then interface means what? They are going to provide some abstract methods, right? Method without implementation. And when you are seeing something as I means, it is an interface, right? If you go to the definition of interface, it is providing one abstract method compared to, which is returning me one integer value, and it is taking one object type, right? And it is returning me an integer value, and it is expecting one input of object type. Object in the sense you can pass any kind of values or not,
Yep.
right? And
Yes.
what it returns one integer value. What this value? A value that indicates relative order of the object being compared. The return value has this meaning. Value meaning less than zero. This instance, okay, forget about this definition. Come to our own understanding, right? So first of all, what you need to do is, right, we can sort the data by using LinQ. That is what we are going to discuss. Let us first understand without using a LinQ, how we can uh, implement this sort functionality, right? How we can make use of the list class sort method to sort the data of complex type. So your class should implement comparable interface, and your class should provide implementation to the compare to method. So in this case, this compare to method return type is integer, and what this integer represents. If the integer what you are returning is greater than 0, suppose you are returning one integer value which is greater than 0, means the current instance is greater than the object being compared, right? So in this case, what is happening? Now you are calling the compare to method on one object, right? And you have to pass one object. That means what? So in this case, okay, okay. Suppose I'm doing here one method. I'm creating public integer compare to, right? Suppose I'm creating this compare to method, right? So in this case, if I want to call this method compare to, right, then what is required? I need to create an instance of this class or not, right?
Yes,
And
yes.
this is employee one. I'm creating employee emp2 equals to new employee 2, right? Then can I call this compare to method like this? Can I call the compare to method like this?
It
In
looks
this
good.
case, right? In this case, who is going to be your current instance? Current instance is going to be emp1, and the compared object is going to be
Imply to.
employee, right? Employee 2. So in this case, this refers to the object in this case, right? In this case also this. So if you are calling this dot salary, What it means employee one dot salary, right? This dot salary means what? On the object on which you are calling this compare to method. So this dot salary means what? The employee one dot salary and object, and in this case obj dot salary means employee two dot salary. Clear?
Yes.
Right? So in this case, what is saying now, according to the business logic, return value greater than 0, the current instance is greater than the object being compared with. If this current instance is greater than the object being compared, then return 1. I'm returning 1. So this will indicate that whatever the current instance, that is greater than the object being compared. Clear?
Yeah.
Right? And the second, return value less than 0, the current instance is less than the object being compared. Right? If this value, right, current value is less than the object being compared, then you have to return -1. Clear? Clear or not? If both the object are equal, then return 0. See, either in this case, the first object value is greater than the second object value, or the first object value is less than the second object value, or it might be possible that both the object value are going to be same, right? Because see, if I am going to compare two number, then first of all, I need to compare first number with the second number, right? If first number is greater than second number, right, then no need to swap. Or if you want to store in descending order, if you want to store the data in ascending order, then you need to swap, right? And to implement this logic, we have to write this code, right? Because we want to sort the data based on some logic. Then first of all, we need to check now, we need to compare whether the first value is greater than the second value or not. If it is greater than the second value, then what we need to do? If it is less than the second value, then what we need to do? If it is equal, then what we need to do? Clear?
Yeah.
And the rest of the thing is going to be handled by the framework, and you just need to implement. See, this is the logic, right? What I have shown you is here. If the current instance is greater than the object being compared with, then you have to return. You have to return
Greater than 0 means 1.
return 1. If the current instance is less than the object being compared, then return something which is less than 0, and if both are equal, then you have to return 0, right? So this is the compare to method, but the guys, if you implement like this, then this is not going to be work, right? Why? Because we have to implement what interface. You see, in this case, I have implement the logic, right? But even though I have implement the logic, it is not going to work. Why? Now, because I have to make sure my class implement comparable interface, right? Now, right? In this case, I need to make sure my class which namespace? What is the namespace name?
The I, take the
Right? Comparable of employee. Right? So you have to make sure this comparable of employee, right? So in this case, you can see this is my comparative, and because we are not using the non-generic collection so that you can use comparable, we are using generic collection, means we need to use the generic version of this comparable interface, and the generic
Hello.
version is this.
So I'm
Yeah.
not able to hear anything.
Sorry.
Is it the case with this?
Hello. Hello. Is anyone saying anything? Guys.
No.
Okay. So see, in this case, I'm not going to implement comparable because it's not a non-generic class. It's a generic class, right? I'm using this is a generic collection. So I have to implement the generic version of the iComparable interface. And in the iComparable interface, I need to specify the type. And in this case, the type is going to be employee. And then I have to implement this compare to method. Right now, if you go to the iComparable, then you will see that input type, right? And this T is nothing but your data you can consider, and this T is nothing but your data in you can see here, and this T is nothing but employee here. So you are mentioning employee of T, then you have to use that T inside here. And here I have to provide implementation like this. So once you provide the implementation, then what you need to do? Right? So now run the application. Data is sorted based on the salary ascending order. Guys,
You're going to, yeah.
right? So the point that you need to remember is your class should implement the iComparable interface, and your class should provide implementation to the comparative method to sort the data. So this is how you need to sort the complex type. And this is not the final one. It is one of the option, which is a very complicated one. We can simplify this option going further, but this is one of the option, right? If your class is not implementing the iComparable interface, if your class not providing implementation to the comparative method, right? Then if you call the sort method, then it is going to give you runtime exception. And if your class implement the iComparable interface and provide implementation to the comparative method, then this class or this thing is going to be warped. Clear? Guys?
Yeah.
So this is how it is going to work, right? It is one of the option, right? So so it is one of the option, but the other options are also there, right? Other options are also there in the sense, if you go to the sort method, right? Currently we are using this version of the sort method, right? But you can see there are other version. This is another overloaded version where it is expecting iComparer interface, right? Where it is expecting one iComparer interface, and let's see how you can implement that. So in this case, you do not want to sort by ID salary, or rather you want to create yours as different mechanism, right? A different mechanism means you want to provide your own implementation, how you are going to sort the data by using this iComparer interface, right? Because there is not only one method to sort the data, but there are 4 different overloaded versions, right? We have used only this one. Now let us see how we can use this other overloaded version to sort the data, right? To implement this, what you need to do, you need to create a class, right? You need to create a class by implementing the iComparer interface, right? So let me remove this. This is not required anymore. I don't want to make our class so much complicated, right? Because if you implement this logic, right, every time the data, see, so what my intention is, if you implement this logic, then every time the data is going to be sorted based on the salary column, right? I do not want to implement this thing, right? What I want is, I want to create a different method, right? I want to sort the data in name ascending order. So how you can do this? See, I have created one class, and that class implement the iComparer interface, right? iComparer interface, and it's a generic type. You can see T here, and this method expecting 2 parameter tx and ty, and it is also going to return integer value. The same logic what I have written inside this method, right? This same logic is also going to be implemented here, right? But here what I'm trying to do is, this is my first object, right? Employee X and employee Y. So this comparer method taking 2 parameter, one is employee X, another is employee Y. Why? Because if you go to the definition, it is expecting two parameter of type T, and here Tx, Ty, and in this example, you can see the T is nothing but your employee. So I'm passing employee X and employee Y. So in this case, this X and Y, you can consider employee X and employee Y, because here T is nothing but your employee, right? And then the logic I have written here, X dot name dot compare to Y dot name. So in this case, I do not need to see. In this case, you might be on one question, sir, how you can directly use the compare to method? This class is not implementing the iComparer interface, right? Then how, sorry, iComparable interface, then how you can use this one, right? In the previous example, we have seen the class implement this one. In the previous example, we have seen the class implement this iComparable interface, and this iComparable interface having this method, right? And this compare to method I can use here, right? Employee, create an employee instance, call this compare to method, right? But in this case, I'm calling this compare to method on the name variable directly, extract name. Is it possible? Yes, it is possible. Sir, how it is possible? Okay, what is the type of this name variable?
String.
String type. Is this string type implement the iComparable interface?
Yes.
Is this one iComparable of string?
Yes.
Right? So if this string class implement this iComparable interface, that means the compare to method is also implemented by the string class or not?
Yes.
Tell me. Right? So this is the reason why you can use the compare to method directly in this case, because this compare to method already implemented by the built-in data type, not only integer or not only any other, right? So that already implemented. Now you want to sort the data based on the name. Yes, you just need to write this thing. Here I have to write the logic by my one. Why? Because this is my type, and this type doesn't implement this compare to method. Here no need to write this logic completely. Why? Because here you are going to call the compare method on the name variable, and the name variable type is string, and that string type or that string class already implement this compare to method. So just only directly go and use the method. So x dot name compare to y dot name, right? This compare to method expect how many parameter? Current instance and the object that you need to be compared. Here x dot name is nothing but your current instance, or you can say object one, and y dot name, it is going to be your object two. And I'm calling this compare to method on the current instance, passing the object that needs to be compared. And this method now it is going to return me one minus, it is going to return me 1, -1 and 0 based on the comparison. And if the current value, it will generate all hash code, and it will compare with the other hash code, whether the hash code integer is greater than less than, right? All the logic is implemented by this compare to method, right? And simply what we need to do is, right now what we need to do is, we need to now we need to use the other overloaded version, right? Which take this comparison, this iComparer parameter, right? iComparer instance, right? Now, can I create an instance, right? Can I create an instance of this class? Can I create an instance of that class? Let me remove this thing so that you should not be confused. So this is my sort by name. It's a class. So can I create an instance of this class?
Yes.
And this class is a comparer or not?
Yes.
Right. So as this class is a comparer, so can I create an instance? Can I pass that instance to this sort method? Now, this class is a child of this one or not?
Yes.
guys.
Yes.
Yes.
So if this is a child class, that means this is going to be its parent class. If I am throwing one object of a child class, is that object going to be held by the parent class reference variable?
Yes.
So in this case, this sort method expect one parameter of I comparer, right? That means it's a parent reference variable. Can I throw one object which is a child of this class to this method?
Yes. Yes.
In this case, is this sort name method is a child of I comparer?
Yes, yes,
Sort by name is a child of this I comparer or not?
Yes.
yes, it inherits from I comparisons.
Yeah, so that's why you can pass this sort name instance to this method. Now this sort method not going to use the overloaded which doesn't take parameter, rather it is going to use this overloaded first. Clear?
Yes.
So now if you
Yes.
run the application, then you will get the data. And this time the data is going to be sorted by the name in ascending order. See, Anurag, Hina, Pranay, Priyanka, and Sambit. The data is sorted based on the name in ascending order. Cleared or not?
It's clear.
Okay. So this is another option. If you don't want to implement that I comparable interface, right, then you can go with this option. And in this case, you need to use the other overloaded version, which takes the I comparer interface, right? And guys, to be frank, in real-time application, we never going to use these mechanisms, right? We never going to use this mechanism to solve, create a class, right? To create a class, implement this iComparer or implement your class from iComparable interface, right? It's going to be a lengthy task, right? And because sometimes you want to sort the data in the name ascending, name descending. Sometimes you need to sort the data in salary, right? Sometimes you need to sort the data based on the ID column, right? So if you are going with that mechanism, then it is going to be a headache, right? So what generally we do is we are going to make use of the order by and order by descending method, which is provided by the system.linq namespace, right? In our coming sessions, when we discussed linq, at that time we will discuss what is all this thing. But now I'm just going to show you the examples. If you are not understanding the concept, right, how this is working, then that is also fine. Once you start LinQ, right, you will get more clarity. So this is my collection. I'm initializing using the initializer. And this is my data, right, before sorting. And here you can see what I'm making use of one method which is provided by system.linq namespace. Now, if you go to this interface, you can see this is the system.linq namespace, and I'm using that system.linq method. And this is my collection. On this collection, I'm calling the order by method, and by using the lambda expression, I'm specifying the logic, right? I want to sort these employees in see, whenever you are using order by, it means order by ascending, right? It will sort the data by default in ascending order. So I want to sort this employees data in ascending order based on the name column. You just need to mention extract name, and then you just need to call the toList method. Now the data is going to be sorted by the name in ascending order. And if you want to sort the data in descending order, then you have to use order by descent. Right now, let me run the application. Okay, let me first show you the data in ascending order, right? Descending, right? Now it is going to be sorting and it is going to be ascending. And this is going to sort the data in descending order. See, you can see the data is sorted in ascending order, and here the data is sorted in descending order. And this descending order means don't think that this is the reverse method. Don't think that this is the reverse method, and don't assume that the data is already sorted and it just reverse the data, right? To make sure, what I can do is I can comment these things, right? I can comment these things and I can directly call this descending method. And then now you will see that you will observe that the data is going to be in descending order, not the reverse order, it is descending order. So this is the logic that you mostly find in your project, right? You are not going to use that I comparable, I compare the interface, all these things. Rather, most of the time, you will see that you will make use of this LinQ for it, right? We will discuss this LinQ in detail. Clear? Guys?
Sir. Yes.
And here we are simply specifying the condition using the lambda expression. You know, this is the lambda expression. And here we are simply specifying the condition that we need to sort the data based on this column. Right? Now, this is the thing. And the last part of this list collection class we are going to discuss is comparison delegate. So we have discussed this is the same thing, right? In this case, we have discussed this I comparer interface, right? In that I comparer interface, if you want to sort data from some number of elements from some particular index position, then you can use this overloaded version. For example, right? Right. So you can see other overloaded version is also there. Okay, let me add a few more items. Right, so 1 5, I'm going to give a 7 8 6 name markup Pratik.
Yes, sir.
No, I'm just giving the name here. Don't yeah, so don't go with the data, right? So what I'm trying to make sure is you are using this method, but if you go to the definition of this constructor, right, you are using the I comparison, I comparer interface. You are using this one. But another overloaded version is there where you need to specify the index and count position, right? Suppose in this case, I want to sort the data from index position 2 for the next 4 elements, then you need to use this overloaded version. Suppose I want to index position 1 and for the next 4 element. So in this case, you will see that this element will be as it is. The next 4th element is going to be sorted and the next 2 elements are going to be as it is, right? Let me run the application. See, the first element is Pranay. Yes or no? Guys, the first element is going to be sorted or not? From which index position we are going to sort the element?
No, first element will not be sorted. Second
Yes.
element.
From the second element. So second element up to next 4th element. 1, 2, 3, 4. Right? From Bhargav, Pratik, and Tay, they are as it is in from the in the sequence or not? Is they are going to be sorted? No. The next 4th element, you can see Anurag, Hina, Priyanka, and Sambit. These 4 elements are going to be sorted. That means you can also, if you are having some scenario where you want to sort some portion of your collection, right? You want to sort some portion of your collection, then you can make use of this, right? Clear? So
Yes.
we have discussed this overloaded version. We have discussed this default one we have discussed, and we have discussed this one. The next one is I comparison, and if you go to the definition of this, then you will see that it's a delegate. And the delegate signature is it is expecting 2 parameter, right, of type T, right? So we need to understand this delegate now. Clear? Right? Guys? So other overloaded version of the sort method is there, which is taking one comparison delegate to compare the data. And we have already discussed what is a delegate. Can anybody tell me what is a delegate? And how to use a delegate?
Callback functions.
Callback functions. Yeah, that is one of the use case of delegates, that is callback function. But what is a delegate? It's a function pointer, right? And whenever you want to use delegate means you need to create one function whose signature should be matched with the definition of the delegate. And when you invoke the delegate, then the function it is pointing to is going to be executed. Clear? Yes or no?
Yes.
That means we need to, if I want to use this comparison delegate in my application to compare, right, to provide the sort functionality, then first of all, I need to create one method whose return type is going to be integer, and that method should take two input parameter of type t. Clear? And that return value and in this case that return value is also going to be the same thing. If x is greater than y, then you have to return 1. If s is less than y, you have to return -1. And if x equals to y, you have to return 0. Right? This is the thing that you need to use. Right? Let us understand this. Right? Suppose you are having this employee class. Right? And suppose you are having this employee collection. Right? You can see this is my employee class and this is my employee collection. Now what my requirement is, I want to use this overloaded version to sort this employee data. Then how we can do this? By using this comparison delegate. So first of all, you need to create a class, right? First of all, you need to create a method whose signature should be same, right? Whose signature should be same with your comparison delegate. Right? In this case, you can see this is my comparison delegate returning integer, taking two input parameter, and I want to compare two employees. So you can see the return type is integer, and this method is taking two parameter, employee 1 and employee 2. And I want this method to be sorted by name. So can I use e1.name.compare to e2.name? In this case, I can directly make in use of this compare to method, because this name it's a string type and this string class already implement the compare to method. And if I invoke this compare to method on this first instance, and if I'm passing the second instance, right, then in that case the logic what I have shown you is it is already implemented by this compare to method. We just need to call the compare to method on the first instance, and we need to pass the second instance as a parameter. Not instance, you have to pass the properties based on which you want to compare the data, right? So in this case, I want to compare the data based on the name. So I'm just calling this compare to method on the name, and I'm just passing e2.name as a parameter to this compare to method, right? Once you implement this compare to method, right, once you implement a method whose signature is same as the comparison delegate, right, then what you need to do, right? And this method already have the logic. This method have the logic to provide the sorting functionality, right? Then what you need to do, once you have this comparison method and once you have this comparison delegate, then you need to create an instance of a comparison delegate. And while creating the instance of a comparison delegate, you know what to do. What we need to do, we need to pass this method as a parameter to the constructor of comparison delegate like this. You can see here I'm creating a comparison delegate. It's a generic type, right? So generic type means you have to specify the type here, and then you need to provide the method name. That is what you want to execute when this delegate invoke, right? And once you create the delegate instance, then it's simple. What you need to do, you just need to call the sort method by passing the delegate instance as a parameter, right? The way we have discussed the delegate concept, right? This is the same approach. We are not doing anything new here, right? Let me show you this thing once more, right? First, this is step 1, right? This is my step 1. Create a method, right? And this method signature should be same or should be matched with the comparison delegate signature, right? If you go to the comparison delegate, right, this is the signature, right? In this case, this is the comparison delegate signature. You can say the return type is integer and it is taking two input parameter. Here in represent input and this is t, and if sometimes you will see out means it's going to be output parameter. In this case, in t means it's going to be input parameter tx and ty, and in this case I'm going to compare to I'm going to set the data of my employee class. So you have to specify the parameter as employee, right? Employee and employee. Two parameter. This is x. If you are confused, make this as x, make this as y, and then you have to call this method like this. This is my step one. Once you create the method whose signature is same as the delegate, then what you need to do is you need to create an instance of a delegate. Step two, right? Create an instance of delegate, right? And in this case, the t what I'm specifying here, employee, and that t what is here, employee. That is the thing that you need to remember. It should not be like that. Here you are passing product and here you are passing employee, or here you are passing student and here you are passing employee. That means what? What is the type you defined in your comparison delegate? The method what you are creating, that method should accept the same type, right? So in this case, the type is employee, and I'm creating an instance of my comparison delegate, generic delegate you can also consider, and I'm passing this method as a parameter. That means when this employee comparer method invoke, then this method pointing to this compare employees, and that compare employees method is going to be invoked, and this method we have the logic to compare the two employees, or this method have the logic to sort the data, right? And once you create an instance, this is going to be your step 3. What you need to do, you need to call the sort method by passing this employee comparer. And now this sort method will do the rest of the thing. This sort method have know the on what logic I'm going to sort the employee collection data. I want to sort the employee collection data based on the name column in ascending order. So now this is sort method know, and this sort method is going to sort the data. Now, if you run the application, then you will get the output as expected. Data is sorted? Yes or no?
Yes.
Right. Now, so instead of creating a separate method, right? Instead of creating a separate method, can I use anonymous method in this case? Instead of creating an instance of a comparison delegate, instead of creating a method passing that comparison delegate as a parameter, can I use anonymous method here? Yes, we have already discussed this thing. What we need to use? We need to use delegate keyword, right? And we need to pass the logic here, right? So if you do this thing, then this thing is not required, right? This step 1 and step 2 is not required. This is nothing but your anonymous method. Now, this anonymous method, or this anonymous method means it's a delegate, right? And this delegate signature is going to be the same as the comparison delegate, yes or no? Whatever signature of this anonymous method, is it the same as this one? Yes, this is the same. So you can pass this one. So you have to return one integer value. This method is going to return some integer value. So you have written the return statement. This method, anonymous method, taking two input parameter of employee type. Yes, here T is employee, so it is taking two employee parameter, and it's a delegate. Delegate means it's an anonymous method. So now if you run the application, it is also going to give you the output as expected. Any question from this one? Why, how it is working?
Can we also use the lambda here?
Exactly, that is the next thing now.
Okay.
That is the next thing. We can also use the lambda expression, right? So we can use the lambda expression. To use the lambda expression, what you need to do, in the right hand side, you need to specify the input parameter, right? So, and in that case, you do not need to specify the type, right? Clear? Here in the left hand side, you need to specify the parameter name without type, and the logic is going to be, this is my lambda operator, and the logic is going to be same. So this is my lambda expression. So if you are using delegate, then you can convert that delegate to anonymous method, and you can also convert that delegate to lambda expression. Clear? Any question from anyone?
Okay.
See, why I'm giving more time to multi-threading, why I'm giving more time to delegate is because of this. Because going further, those things are going to be used. And if you understand the delegate concept, then it should not be that difficult to understand this concept. Because this delegate, from the day one, I'm saying delegate is extremely used by the framework, right? How? See, this sort method is provided by the framework, and this comparison method is also provided by the framework, and this comparison, it is nothing but a delegate. That means delegate is used by the framework. So that's it for our list collection class, right? Many other methods are there, like find method, find all, right? Those are, we are going to discuss in detail once we start our LinQ concept, right? Any question from anyone related to today's session, they can ask me.
Sir, one question.
Hmm.
Can we use the type on any class or any interface?
Sorry, what is your question? Can you repeat? Type?
Yeah, type that angular bracket and the type you mentioned, not T. Can we use that on any class, any instance, or it is restricted to particular inbuilt classes or interfaces?
So I'm not exactly understanding what is your question.
Suppose
Any,
I comparable is a interface. Okay.
right?
So I comparable without non-generic is also there. I comparable
Yes, yes. I comparable.
employee is also there.
I comparable non-generic is also available, right? If you are, if you want to provide the sort functionality, right, in your non-generic collection classes, then in that case you need to use this one, right?
Okay.
But in this case, we are working with generic collection, right? So in
Yeah.
this case, you can see I'm using this one, and I'm going to provide the implementation here, right? You can see this class having one method. What is that method? Implement interface through. See, you can see implement interface through. I want to implement the interface through IT. See, you can see I compare it to now. Now you can call this list of employee dot sort method, list employees dot sort method, right? See, what is the fail to compare two elements in the array, right? Why it is failing? Because in this case, it is not a generic list. What is it's not a non-generic list. It's a generic list. So it's a generic list means you have to provide implementation to your employees. So you have to provide implementation to your employee, right? Right. So in this case, you can implement like this. So what is this? The current instance is going to be your this dot id compared to other dot what is id, and this is the non-generic version and this is the generic version, right?
Yeah. So this Angular bracket employee you have written, so that
Yes.
can we apply to the user defined classes also or
This is a
interfaces?
user defined class. Na? In this case, what I'm passing employee, it is nothing but your user defined class. Na? What is this? This employee is a user defined class only.
I mean, instead of this I comparable, can we apply this to the like user defined interface?
If you implement this I comparable with user defined interface, then how it is going to know? Right? How it is going to know? It is expecting one interface that should be I comparable. Right? It is expecting one interface that should be I comparable. Right? If you are not providing this implementation, right? Let me comment this one. Let me comment this one. Right? What it is saying? It is saying at least one object must implement I comparable. If you implement other interface, then how the framework will come to know whether it is a see if other interface is there, then this compiler, the framework will not know. Framework will know that I comparable should be implemented. If it is not implemented, then I cannot implement this, because this sort method is provided by the framework, and this sort method going to make use of this I comparable interface. And if this is not I comparable interface, then I cannot sort the data, right? And if you want to create your own interface, I have already shown you the example now. I have shown you the example. You can use iComparer, right? In that case, you need to create your own class. That class implement this iComparer interface. You have to provide the logic. You need to create an instance and pass that instance as a parameter.
Okay.
All right. Any question from anyone else? Guys?
No, sir.
Okay. Okay, fine. That's it for today. And we have class tomorrow, right? So you guys decide whether we need to take class tomorrow or Sunday. Only one day. Guys?
We can take on Sundays, maybe.
No, I'm asking if most of the people are interested in Saturday, I will take on Saturday. If most of the people are interested in Sunday, then I will take class on Sunday. But both the days not possible. Okay, do one thing. Just mentioned in the group on which day you guys are interested, right? Personal preference you can provide on the group whether you are interested in Saturday or Sunday. The most of the people are if interested for Saturday, I will take classes on Saturday. If most of the people are interested in Sunday, then I will take the classes on Sunday, right? But it's going to be a 3-hour class from 7 to 10. All right. Thank you guys.
Hi, Pin.
Hi. Hello. Hello. Someone is saying something?
No, I'm not saying it, sir.
Okay, fine. Thank you guys.